There we go. I'm sorry, it always just takes a minute for this to get running. But alright, so today I'm doing a really fun hack with the Amazon Dash button. I'm not sure it's going to work, but you can tune in, and either way we'll end up with something that works for the purpose I have in mind, which is an object that will help you upgrade your mind as well as your Dash button. This is a little hack that I've done in various forms in the past that is designed to help you attain a hypnagogic state of thought, and that means that you are in this state between waking and sleeping, which is very ripe for creative thought and problem solving, and has been used throughout history by different people such as Dali, Edgar Allan Poe, etc., supposedly. What I can tell you is that it works. If you think about something, while you're waking up or falling asleep, your mind is clear from other distractions, and it's very fruitful for creativity and other applications. So, I want to hack an Amazon Dash button with a light blue bean from Punch Through Designs. This is a Bluetooth Arduino that is, you program it over Bluetooth low energy, so it has no actual, no USB connections of any kind. You simply program it over Bluetooth from your phone or other mobile device, or from your computer. It's fantastic. It's got a built-in temperature sensor, accelerometer, but that's kind of battery hungry, and a programmable RGB LED, among other things. And then plus it's got these 6 digital and 2 analog I/O pins. So I really love this thing for portable and wearable hacks. So I thought it seemed like about the right size to fit inside a Dash button. Let's see if we can't replace this. And I haven't done this before. It's a live hack, so we'll see how it goes. I'm going to move the code out of here. I'm using an app for the light blue bean called, what is it called? Punch Through Bean Loader? Bean Loader. Yeah, it's this one. And you can find it on the App Store. They also have a version for Android, I believe. But let's get to taking this thing apart. I already took the sticker off so I could see that there are, as you'll often find, screws underneath. These are actually Torx screws, but with a little bit of judicious application of a small flathead, I could actually get them to come out. And I did test this partly, but I haven't gotten any of the screws all the way out yet because I wanted to save that. So basically, I am putting the screwdriver into the one of the slots in the hex format Torx screw, and applying a lot of pressure and very slowly turning it so that I have a lot of friction between the screwdriver and the screw. And I'm hoping that I won't just strip everything out. It's kind of working so far. I also accidentally pushed the button. Alright, and then I also looked at an online teardown to get a sense for what we might need to replace. And it shows, I forget where I was going with that. Oh yeah, that the thing is glued together as well as screwed together. So there's some kind of life lesson there, as all things that rhyme are clearly life lessons. But hopefully that won't be too hard to get apart. Cool, so that's one down. Let's try and get the others. Again, applying a lot of pressure and turning very slowly so that I can get a good grip. And that'll sort of minimize the chances of me stripping out these screws completely, because I'm going to want to put them back in place afterwards. Or I might see if I have some other little screws that I could replace these with, in fact. That would be the optimal scenario. I do have a Torx screwdriver, but it's at home. So, good job on that, me. Another thing that you can do is you can like solder something else to the screw and use that as a lever if you really are sort of hard up for options, but then you might end up melting the surrounding stuff. And once I have this actually a little ways out of its socket, I can use pliers to turn it. Just gotta get far enough. That should do. This one's being a little bit more reluctant, so I'm going to try it with the pliers. Ooh, not enough yet. Okay. I have stripped it a little bit, but I think it'll be workable still. Ah, these pliers are not good enough. Oh, you know what? I've got them built into this thing too. I'm using a Leatherman squirt, which I really dig. Ah, okay, let's see. Can we get more? Oh, there we go. Cool. Beautiful. Okay, 2 down. 1 to go. Put these back together again. Yeah, this is the best little multi-tool like I've ever used. I love it so much. I've also gotten like 3 of them taken away by airport security in the past. Oh, I drove that one a little hard. That might be fairly stripped. We'll give it a couple more shots and see what happens. Keep pushing that button. Inside of here, the original button is powered by a AAA battery, which is actually soldered onto the board. We don't care about that because we're going to be using a bean. And because it can be a pain to get this thing together and apart, and the bean runs on a 3-volt CR2032 coin cell battery, I have looked up some code on the Bean tutorial website to see how you can put it in a sort of sleep mode, a dormant mode, with a pin interrupt, which basically means that it will stay off until I push a button that I will attach to it. Oh, this one's pretty well stripped. You good. Nah. Well, I'm honestly not too concerned about that side of it. I'm gonna try and just sort of brute force this apart, and then I'll pry that part up and probably end up putting a new face on this or something. Sorry, dash button. You are coming apart. And now I am very much brute forcing the glue connection with my knife. I'm doing this, cutting very much away from myself towards the table. If I had a Dremel rotary cutter tool, this would probably be easier. But again, I have one at home and not at the office. I'm being very careful so that the knife doesn't fold up and cut me. It takes a lot of force. Oh, there we go. The seals are breaking. Cool. Now I'm gonna stop using the knife and switch to a small screwdriver in order to sort of pry this apart. Good, good. Yeah, it's definitely not gonna be super pretty. So it goes. I do kind of want to reuse the top of this because it holds the button in place, and I'd like to keep that intact. So maybe I'll give it one more try at the other screw. That looks pretty well stripped though. I have some needles here actually. So I think if I try to solder one of those to it sideways, that should give me some torque. It's not elegant, but I'm gonna try it because I really want to try and keep this somewhat intact. This livecast is not intended to be used as professional advice. We aren't going to get something super pretty out of this, but it should work pretty well. Now I'm hoping this hasn't just completely melted the threads. Ah, crap. Not enough adhesion. If I'd done this before the screw was stripped, actually, it would have probably worked better. Okay, we'll try prying again. What I'm really trying to get at is the innards so I can show you what's going on inside here. Ah, yes, that's a good sound. Let's try on the other side here. Give me another little crack. Close enough. Okay, and now I'm just gonna brute force this apart. Oh boy. I'm again not using the knife, so it's a little bit safer than trying to cut this apart. Okay. There we go. Cool. So it appears that the circuit board is what's screwed onto the top. And at this point, probably what I can do is, if I can get enough space here, yeah, I might be able to just rotate this whole thing off. Come on. Use it like as a screwdriver for itself. And there's no actual circuit connection between the two, so... Haha, yes. Come on. Rotate. It really does not want to rotate. There we go. Ah, finally. I'm just rotating this whole thing off. And fortunately, you know, the soft plastic of the top also is softer than the connections of on the board. So it hasn't done any damage. So there you go, 3 ways of unscrewing something. First, if you don't have the right bit, I don't actually recommend the second 2 of these. The first one is, you know, you can try and use a similar screwdriver and hope that that works out for you. Oh, hey! So this one is actually not an original dash button. It is a reinvent button from Amazon that is intended to be reprogrammed. Oh, but I see. I thought that maybe this one was not soldered in and just had this like holder thingy, but it does appear to be soldered. Or at least stuck on very hard. I think maybe it's just stuck. Huh. Yeah, that's glued. And are these soldered? Okay, they are. Or at least attached with something conductive and adhesive. Okay. So over here we've got the button. And where's our LED? It's probably this guy, DS1. Yeah. And that is not going now. And I wonder if I put the top back on, if it will. Oh yeah, I'm going to take out that last screw so that the top can be reapplied. I can just screw this out from the other side now. Ooh. Ah. Cool. The nice thing about this is that the button, the big pressy button, is not actually, is rather attached to the main part of the top, which is nice because it's got this little sort of rubber springy flexible piece. It's at least holding it in place for now, so that means that I don't have to worry about having the pieces come apart and fitting them back together nicely again after the fact. Okay, so this is cool. The nice thing about this little nestly bit is that it might be able to hold our light blue bean in place as well. It looks like maybe I want to cut off some pieces in order to make that actually useful. But I have got side cutters and it's made of soft plastic. Ha ha ha. Ha ha ha. I told you this is what the Wednesday. This is not like our fancy schmancy smart people talking about electronics segment. This is us messing around in the middle of the week with electronics, trying weird stuff because it's fun. Happy hump day. Cool. And I'll probably have to dig out a piece for the battery as well. But basically what I'm looking to do is fit this entire light blue bean into here and put it button down here so that I can use that instead of the original dash button. And we're pretty close. Like, I was not sure if the bean would actually fit in here, but it looks like an almost perfect fit, which is really cool. So yeah, so that's just a few millimeters down. What if yeah. I'm just gonna cut into this again with my pliers. And where do I want the button to land, actually? Oh, look at that. So good. Sort of vaguely down there-ish. Alright. So if I do there... And I have got a couple of other buttons to apply here. So I've got this one from a sort of knockoff tiny little kit, or lily pad kit. It's just like a no-brand knockoff of the sewable ones. And then also a really tiny tactile switch. The one on the original dash button is very, very small. Doop, doop, doop. So, I don't know. Do I want to use that one? How do they feel? They both feel pretty nice. And I love the sound they make. I might go with the bigger one just because I want it to be harder to hit so that I don't accidentally run down the battery. Cool. So let's solder that on. And I also need some kind of feedback for it to give, so I'm going to attach a haptic motor as well that will vibrate when it is time to, like, notice that time has passed. Or actually, I kind of need that for another project. No, that'll be fine. So I'm waiting for my soldering iron to warm up right now. Here's our 3 little screws. I'm not going to actually use those again. So how am I going to reattach this, I wonder? Because I want to be able to get in here and replace the battery from time to time. So I'll think about that while I'm doing all this button and haptic attachment stuff. I'm going to get my wires ready by stripping them for the button. A side effect of putting all my strength into prying that thing apart, while also not totally destroying it, is that my hands may be a little shaky now. Forgive me. Cool. Gonna twist on these so that they are nice and tidy. If you're going to CES, I'll probably be walking around with 1 or 2 of these hacks that I'm demonstrating. Yesterday we looked at the EEG hack that you can do with a NeuroSky MindFlex headset from a Mattel MindFlex Dualgram, so that was pretty fun, and yeah, I'm hoping this one ends up exciting as well. Okay, so yeah, just want 2 sides to this button. The way that the interrupt code that I found is structured is a pretty common way of wiring up a button. It's really nice because when you're doing a button, then you may end up with a floating number, a floating value for the pin it's hooked up to. If the button is like normally open, so there's no connection, It's not connected to either voltage or ground, so its current value is usually going to be somewhere in between the two. And the way that you fix that is by putting a resistor between it and voltage or ground, which means, and that's a pull up or pull down resistor, pulls it up to the voltage line or down to ground, which gives it a constant value that you can compare against so that you don't get weird false positives and negatives. In this case, the bean has an internal pull-up resistor you can use. Input pull-up is the type of pin it is. And yeah, so that's what I'm going to be working with. I'm going to tin this guy too. Tin our button. And tin the other pads of the wire. So basically the code is an interrupt. The bean will, we just dropped that. That's step 3 in the process, is drop your wire strippers. Yeah, the code basically sleeps the bean until it sees that value of that pin change. The nice thing about the input pull-up variable type or pin type is that I don't have to worry about adding a resistor in line with this. I can just solder the button into the controller. Again, hands are a little shaky from all that. Come on. I want you guys to get nice and cozy. There we go. Cool. Now I'm also going to need to isolate this from the body of the bean. These little protoboard holes aren't actually attached to anything. So maybe I'm best off just soldering it directly to those pins, actually. That could be easiest. Oh no, but it's got to get to ground as well. Never mind. Okay, cool. So these pins could actually be much shorter than they are, or these wires. I'm going to cut them down. And then after we've got this in place, we're going to trim down that plastic piece so that it's held at the right height. Now what pin is our button on? We're looking at pin 0 is the input pull-up pin. I want to make sure that that looks good from the other side. No, it doesn't. Okay. Cool. Let's get you a little closer in on this. Because I think it can be useful when we're doing the soldering. There we go. That's much nicer. Okay, so now we've got to solder it into the ground pin as well. Solder it into the ground. I'm sorry. Maybe I'll do it. I'm debating like what the best way to arrange this is. Oh, I could put the wires underneath and that'll isolate it. But it will also make it a sort of variable height, like it might get squashed down away from the button. But I think that's fine because the button has enough flex in it. Like this button has enough flex in it that it'll be able to be pushed down further if the button sort of retreats. Okay, cool. So this is, we have the button attached to the right pin, but it also is insulated from the actual connections on the board, which is nice, by the insulation on these wires. And if it shifts in position, then that's fine. Cool. Next up, the haptic motor. The nice thing about the haptic is that it has a little adhesive on it, so I can peel that off and attach it wherever I want, and it'll just kind of stay there. My question right now is, where do I want the haptic to actually be? It might be nice to actually have it underneath the button, because that'll hold it in place, and also then I'll be able to sort of rest my finger on the button and feel the feedback. Because basically I just want this to do sort of one round of timer each time I push the button. So it'll be, like if I push the button, it'll wake from sleep, then wait 5 minutes or 7 minutes or whatever, and then it will vibrate to sort of wake me up again. And then I'll be able to push the button for another round if I want. However, this does make it a little ugly in terms of like its arrangement. Like their battery is down here, then you got all this thick stuff over here, so maybe I'll put the haptic on the bottom. Then I just have to make sure that it's sort of well attached to the chassis so I actually feel the vibration. Let's see how we're shaping up here. Yeah, see, that's obviously too high. If we have it down here, how would that be? Actually, then maybe I could just put something underneath. That kind of works, actually. Button placement is not optimal. I want it to be centered under there. Actually, that's pretty good. So if I were to stick something sort of placeholder down here, and then have the haptic motor on the bottom here, it's still got a little space there. So maybe I use like a little hot glue or something else to space it. I can also use foam tape, which is always a good like insulator and sort of space filler. I think for now I'm just going to solder it on and see what happens. Yeah, I don't know, if I put something underneath. Will that be well placed? No. That's kind of bulging the button out no matter what happens. Well, I don't know, actually it could work. Yeah, okay. I'm gonna actually try this like this. And I've got the haptic motor on pin 1, which is fine. I'm gonna solder it from this side again. And then the other one just needs to go into ground, like before. I'm gonna use the other ground pin. We've got a couple of different ground pins that we can use here. Haptic motors are nice. They're little vibration motors. In case you aren't familiar, I've just been pushing these wires through so that I can solder it all together. Yeah, haptic motors are designed to give vibrational feedback. So for like, phones or other wearable devices. I do consider a phone a wearable. Anyone with a phone is basically a cyborg. Yeah, and then everything is kind of nice and tucked together, which is cool. And then I don't even need to use the adhesive on this thing, which kind of frees me up. Cool. I can also kind of use the little proto board holes as a guide for placement, so I can see when I've got it centered. Cool. Okay, so let's get to soldering these in place. The other really nice thing about the bean actually is that it has labeling on both sides of the board, which is pretty unusual. Like a lot of times you'll see labeling on one side, but not the other side, which when you're trying to build something that lives in an enclosure is really annoying. Not to mention the fact that sometimes the underside, for example, if you're labeling a shield, right, and you have the silk screen labeling on the bottom of the shield where it plugs in to the controller, then you're never going to be able to read those pins again. And if you want to, oh, it's so frustrating. So this one is just really nice to do that. Ooh! I just got a vibration. I probably accidentally oh yeah, you know what happened? I accidentally shorted with my, I shouldn't have been soldering with the battery in. But since the ground wire is soldered in over here, I shorted the battery case to pin 1 and that made the motor go. Because the positive side is facing up. Alright, cool. I'm trying not to stress these connections too much, but at the same time get it all placed the way that I want it. Now I'm going to find some non-conductive things to shove underneath here and try to get it placed very nicely. And also on the side here where I'm going to have to sort of hold it to one side. And I think I'm probably going to use some leftover foam for that. But in the meantime, let's just test this and I'll show you what I mean about the interrupt. So this code shows, okay, you have a pin change interrupt library. Zoom out a little bit. Yeah. And this is Arduino code. If you're familiar with Arduino, it's just Arduino code. I'm calling it amble because it's the opposite of dash. It's sort of helping yourself think slowly and freely instead of moving constantly from one thing to another. It gives you little timeouts. I haven't finished editing this yet. I have just been adding in the output for the haptic motor. So we're setting the input pull up on pin 0, that's our button. The comments say, you know, it's an external library, so all you have to write is attach pin change interrupt to pin 0. So when the pin's value changes, then it interrupts. So the pin value is going to change when I push the button because it's pulled up to voltage when nothing is happening, when the switch is not open, and then it's going to be pulled down to ground when I push the button. Alright, so sleep all the time. That's all that's in our loop. And then you have the interrupt code that's going to happen when the button is pushed. And pin changed is the name of this other function that you're running. And you can put whatever in this. So it's going to set the LED to all red. Then it's going to sleep for 100 milliseconds, a tenth of a second, and then turn it off again. So it just does a really brief flash of your LED. What I'm doing is adding a little sleep function, so it's going to sleep for 5 minutes, 300 seconds, which is 300,000 milliseconds, and then I'm going to make the pin that the haptic motor is connected to go high. So let's do that. Which involves first removing the comment from the sleep. But you know what? I think I'm going to cut out that. I'm going to omit the 5 minutes sleep while I'm testing this, just so I can make sure that everything is working. I'm going to have the motor vibrate for a full half of a second. This is not super exciting. I'm just typing words on my phone. But I do like the built-in editor. And one other cool thing is that they apply this extra line to your keyboard, so it's really easy to enter code. I'm not sure if that's part of the Bean app or if that's like something that you can enable in iOS. I think it's part of the app, and I really like it because it makes it so much more convenient than toggling constantly back and forth between different parts of your keyboard. One, low. And that's all. Okay, so maybe I'll actually just combine these together. Yeah. No, and I'm just gonna have them both go for like half a second. Oi. And I'll put this commented sleep statement at the start. Okay, well fine, you're not gonna let me copy it like that, that's fine. I think the example code from the website had a different indent structure. It keeps wanting to add an extra space as an indent on new lines. Okay, so now we've got the commented out code waiting for 5 minutes. Actually, you know what? Maybe it should do it at the start for feedback as well. Yeah. So I'm gonna rewrite it in a moment so that it has this stuff, which is like turn the LED to red and turn the haptic on, wait for half a second, and then turn them both off. I want to do that at the start and the end of a cycle just so I have feedback that it's running, because it's going to do nothing for 5 minutes. Alright, cool. So I think this is ready to go. I could be wrong. We'll find out. So basically now I'm going to hit this compile button, and it asks me whether I want to compile for the Bean or the Bean Plus. I'm using the Bean, which, there is a Bean Plus out there, which is slightly more powerful, and it has a few extra pins and things like that, but it it's not as small, and for me, like, size is very much a consideration, and the fact that this one runs on a coin cell and everything is just incredibly convenient. So now I'm going to hit this. We are connected, we are compiling and uploading. One thing to note is that in order to compile the code, you have to have Wi-Fi access. So if your phone has no data or Wi-Fi connection, then you're gonna have a bad time. And we're just uploading over Bluetooth right now. Yeah. Okay. So right now it should be sleeping. Where's my focus? There we go. And I want to make sure also before I close this up that there's no way that I'm going to short out the button on the haptic case. But that doesn't seem to be happening. Oh, okay. Right now it's just constantly vibrating and the LED is not on. So that means that my connections are both good, but something is wrong with the code. Ah! Okay, gonna take out the battery. Ah! Take out. Okay. However, it doesn't start until I push the button, so I'm just gonna push the button back in right now and have a look at my code. Okay, so pin 1 is an output, When it changes, oh, well, it's getting to the, Oh, I should make sure that the, both the light and the haptic motor are initialized to be off. So I'm going to add a couple of statements here. bean.setLED to 0, and digital write 1 low. That still doesn't explain why it would only happen once I push the button, though. I got no compile errors. This is the first time that I've used the interrupt pin code for this, so it's possible that it's either been updated since then, since the code was published, or there's just some weirdness about the code that I need to understand that I don't yet. So when the pin changes, then run the function pin changed. Function pin changed means set LED to red. Why is that not working? That's so strange. The thing specifically that is strange is that the LED is not turning on when the haptic is. Like, that's something that's pretty foolproof with this board. Oh, you know what though? It didn't turn the LED on either when I pushed the battery in, which usually it does, so maybe the LED is just dead. Let's try uploading the blink sketch and see what happens. That would be sad, but understandable. And it's possible that several of you are yelling at me right now in the comments. I just want to say I can't see them right now, but I will soon, and I will definitely heed what you're saying. Upload is... Nope! Okay, it works. Well, let's see. Is there any extra setup in the blink sketch that I didn't do? Bean.setLED, da-da-da-da-da. Huh. There doesn't seem to be anything here that I'm missing in my sketch. So what if I comment out the haptic control? Ah! I'm including this in the stream mainly because I think it's useful to see other people having issues, and also how you go about troubleshooting them. So it's possible this is a very elementary error, and I just haven't had my caffeine yet, which is true. But I do still want you to see this because I think it's interesting. Okay, let's try that again. Still uploading. Alright, upload is successful. I'm going to also separate these guys so that there's no possibility of shorting. We've definitely got the haptic on pin 1. We've definitely got them both wired into ground. Oh, my hand is hitting the thingy. And the LED just totally isn't responding. That's really weird. Huh. I'm very surprised that that is happening. But okay. My assumption is that there's some aspect of interrupt loops that I'm not familiar with just yet. And so what I'm going to do is close this out, go do some research, and then be back. But you can see this soon on Hackster.io as a project, and I assure you we will have all the troubleshooting done. In the meantime, you can check out my stream from yesterday about hacking into the Mindflex EEG headset and turning it into something a bit more comfortable. And that will also be up as a project soon. There's also tons of cool stuff on the main page of Hackster. If you haven't taken a look around at cool projects that people are publishing for hardware hacking and more, then that's going to be a pretty fascinating Wednesday afternoon activity for you. I hope you have a good time clicking around, find some cool stuff, maybe some inspiration, and I will see you again soon. Happy with a Wednesday.